We are looking at an example of a quadratic equation. This is example number 6, and we want to see where things get a little bit more trickier or less obvious, right? So sometimes, remember, with any quadratic equation we want to work towards a standard form, and so I'm going to give you one here that is minus 3x squared, right, minus 3x plus 18 is equal to 0. So what is important to note over here is that each of these are multiples of 3. 3 can go into 3, 3 can go into 3, 3 can go into 18, right? So we can make this look a little bit more friendlier. And so we can factorize it because it's already in standard form. It's already equal to 0. And we try and pull out a common factor first. Okay, so my common factor is negative 3 because that goes into each of this. That is a common factor. We're going to break it down and we're going to say if I take out negative 3 times what will give me negative 3x squared? Well, that's multiplied by x squared. Negative 3, so a negative times what gives me a negative over there? That's going to be a positive. 3 times 1, and so it's just going to be x, will give me negative 3x. And a negative times what will give me a positive over there? That's going to be a negative. 3 times 6 will give me 18, so that's got to be 6 is equal to 0. Okay, I can factorize this part over here further and I can say, okay, that's negative 3. I break this down and I say factors of 6, such that when I minus the factors of 6, I get 1. That's going to be 3 and 2. That's going to be x and x. Okay, so here I've got positive and negative, and that must be equal to 0. So now I've got 3 factors. This is the first factor. That's going to be considered factor A. That's going to be considered factor B. And this is going to be considered factor C. Okay, according to the zero product property, either A must be 0, and clearly A is not 0, so I'm not going to be concerned with it much. B could be 0 or C. So when we work that out, we can say, okay, that's x minus 2 is equal to 0, or x plus 3 is equal to 0. And this here implies that x is equal to positive 2. And that comes from adding 2 to both sides in order to get only x. So I say plus 2 over there and plus 2 over there. And I cancel that. I get x on its own. And I get 2 on this side. On this side I can say minus 3 because I want to get rid of the positive 3. And whatever I do to the one side, I must do to the other side in order to maintain an equivalence. And then that cancels with each other. And I am left with x is equal to negative 3. Okay. In terms of the examinations, it's not completely necessary to show this step. Right? I'm just going to put there not necessary to show. Okay. However, you will get a mark for this. You will get marks for this, and it's very important that you show that it is equivalent to 0. Okay.